All right, so when it comes to separation of variables, first off, we have done stuff already before called solving differential equations, okay? What did it mean when we were asked to solve a differential equation? You're finding the original equation from a derivative, right? So when we are doing that analytically, we are finding original equation from the derivative, given the derivative. So when we first introduced that concept, solving for finding a differential equation, I gave you the derivative, and we did integration without boundaries, because that's how we started integration. We did integration without boundaries. We put the plus c there, and then you were given like an initial condition. F of 1 equals 0, and we plugged that in to solve for our original equation. So what we did for something like this, we're given dy dx is 2x. We integrated 2x with respect to x. The integration of 2x is what? X squared, and we said plus c. Sometimes we were given that original point to plug in and solve for c. Sometimes we just left it in the general form, okay? So far, we've only really integrated with respect to one variable, x, or it was integration with respect to t, or whatever. But if something was in implicit form, okay, would we be able to integrate something like that currently? No, because we have both an x and a y. So that's what we're learning today. If we have two variables, how do we integrate that? The good news is you really know all of your integration rules already. So all you have to learn is the beginning part of this, which is why it's called separation of variables. The first thing that we do is separate the variables. Okay, and typically with this, we do multiplication and division. D-I-V. There's an I in there somewhere. And so by separate the variables, this is really where we talk about moving all of the y's to one side and all the x's to the other so that we can integrate both sides. So then we will integrate both sides of the equation. So once you've separated your variables, if all your y's are on the left, you can integrate the left side with respect to y. You can integrate the right side with respect to x, all completely normally, okay? And then we end with solve for y, because of course your original equation of y equals is your final answer, always, okay? So we're going to use that exact example we just had in order to help us see what this looks like. So if I am going to separate my variables first in example 1, this means I need to leave my x's on the right-hand side, and I need to get my y's over on the left-hand side. So if I would like to get this y over to the left, what do I have to do with it? Divide it. Now, there's really nothing, I don't want to divide dy dx by y, so I'm going to make it 1 over y. We okay with that? Now, even that dy dx is going to get split up for us because we want to integrate one side with respect to y. We want to integrate the other side with respect to x. So if I take that and treat it like a fraction, dy over dx, I'm going to leave the dy on this side, and I'm going to move the dx to the other side by multiplying it over there. So on the other side, I'm going to have 2x dx. Then all we really have to do is integrate both sides. So if I integrate this side, I'm going to integrate with respect to y. If I integrate this side, I'm going to integrate with respect to x. So you kind of have to treat them both a little bit differently, okay? Now we already know this is why we left this till now, because now we know how to integrate 1 over y. What does 1 over y integrate to? ln of the absolute value of y equals, what does 2x integrate to? X squared, and you really only have to put that plus c on one side, because if you put a plus c on both sides and then you subtract a c from both sides, it's just a constant on either side. So really we can combine them both on the 1. So we'll keep it on the x side. Now, we've done step 1 and 2. Separate your variables. Integrate both sides, one with respect to y, one with respect to x. The last step then is to solve for y. So if I want to get y by itself, some of us didn't remember this on our test, how do we get rid of ln? Switch it to exponential form. E gets rid of ln. Now, I'm only going to show this part one time here. This looks a little bit weird over here, doesn't that? Because what's the issue with the c? Yeah, it's like up in the exponent, right? So currently the way it stands, I really don't like that notation because what do I still have to do with my initial condition? I have an initial condition we haven't touched yet. Yeah, I still have to solve for c. And I don't really want to solve for c if it's in the exponent, okay? So let's review exponent rules. If I have two things added together in my exponent, is there a way to separate that out? This is the same as this. Because what do our exponent rules tell us? This is kind of like going backwards, but really our exponent rules tell us if I had two base e's, I keep the base e and I add the exponents, right? Well, now, if you have that way, this is just e to a constant, isn't it? And e is just a number. So really, that whole thing is just another constant, correct? So what we're going to write that as is write it as a big letter C in front of the e to the x squared. Now, if you want to notate your c's differently, make one like C1 and one C2, you can. But we haven't even solved for c yet, so does it actually matter? No. So we're just going to write that as a big C out in front because that e to the c is just going to be a number. Now, the way it stands, I can actually solve for c. So I have y equals big C times e to the x squared. So anytime you have that up there, I don't expect you to go through these steps. I would go directly to this now that we've talked about solving for it. In this place now, we have y of 0 equals 2. So what are we allowed to do with that? Yeah, I can plug it in. 2 is my answer for y. 0 is my x, right? 0 squared is just 0. And e to the 0 power is what? 1. So what is my big letter C? 2, yeah? Therefore, my final equation is going to be y equals 2e to the x squared. Once you solve. Questions about that? All right, so again, we have dy dx equals 1 over x times y. First step is to separate my variables. So what variable do I need to move to the left? I need the y to go to the left. So how do I move the y to the left? Multiply it. So I'm going to move the y over multiplied by dy equals, what's going to be left on the right once I've moved the y over? 1 over x, and I'm going to move my dx over by multiplying it. So my first separation of variable steps will look like that. We all okay with that? Then we integrate each side with respect to its variable. So if I integrate just y, what are we going to get? 1/2 y squared equals the integral of 1 over x is what? ln of absolute value of x, and this is the side we'll put our plus c on. So then just like every other question, we need to solve this for y. So what's the first thing I need to move? Multiply by 2. So I have y squared equals 2 ln x plus c. And then what do I have to do to get y by itself? Square root. Now, when we square root, what do I never forget to put in front? Plus or minus, because that actually matters in my solving. So my y is going to be equal to 2 ln x, or the plus or minus square root of 2 ln x plus c. Now, we were given an initial condition to solve for c, yes? All right, so let's use it. I'm given the point 1, -4. What does the -4 go in for? The y. So I've got -4 in for y. And I've got what in for my x? 1. What is the ln of 1? 0. So I have then -4 is equal to plus or minus square root of what? C. So if I'd like to solve for c, what do I have to do? Square both sides, which tells me my c is equal to what? 16. Yeah. So in the squaring, you just get rid of the plus or minus. So our final answer is going to look like y equals plus or minus square root of 2 ln absolute value of x plus 16, all under the square root.
And this is finding the equation, so
That is our equation. Yep. So it's like find the different or solve the differential equation. And this time it's just separating our variables. All right. So first we're going to write in example 3 the differential equation that models the verbal statement. Then we're going to solve it. Okay, so what does this language in example 3 bring back to mind? Yeah, we have rate of change, we have related rates, all that. So if it says the rate of change of r, how is that written? dr dt is proportional to, do we remember that kind of language? Equals a constant k to the square root of x, or the square root of r. Proportional to should be square root of r multiplied by inversely proportional to is over. Okay. Hang on that. All right, so we're going to go with this. Proportional to is generally multiplying. Inversely proportional to is dividing. So if we use this, anytime it says proportional to, you want a constant k out front. Proportional to is a multiplication. So if I want to separate my variables, what variable do I want to take to the left? R, the one that's on top of the dr dt. And so that means I'm going to divide that. So I can either write it as 1 over root r, or I can prep myself for my integration and write it how? R to the negative 1/2 dr is equal to, what's left on the right-hand side? K, which is just a constant. And what else would I move over there? dt. So now, when we go to integrate both sides here, okay, I need to integrate both of these. Integrating r to the negative 1/2 is going to go back to r to the 1/2 with what out front? 2 equals. Now, think about the k. We've been doing some of these, and it showed up on that Chapter 5 test as well. Integrating something with respect to t, it's just going to be what? kt. It's not going to be 1/2 k squared because we're not integrating with respect to k plus c. Yes?
Yes.
Now, what should we be solving for? This one doesn't give me an initial condition. Don't expect to always get the initial condition. Sometimes we just want to integrate and solve for r, or whatever the variable is on the left-hand side. So if I would like to solve for r, what do I have to get rid of? Divide everything by 2. Now, quick question on that. If I divide this stuff by 2, and I'm not even solving for c, does it matter if I write it as c over 2 or just c? No. It really doesn't. So I can make this 1/2 kt plus c. Because really, if I don't know what that c is, dividing by 2 doesn't matter. And that's an r to the 1/2, so how do I get rid of that? Square both sides. So I'm going to have r equals 1/2 kt plus c, all squared. If it does not give you an initial condition, you don't need to solve for c. You just need to solve for the variable on the left-hand side. And that is it.
How did we